Have you ever just looked up and wondered how our solar system is put together? I mean, it's not just a jumble of planets floating around, right? Well, it turns out it's a super organized system with two, let's call them neighborhoods, that are completely different from each other. So today, we're going to take a tour and figure out the logic behind our own cosmic backyard. And it all really boils down to this one big question. How can you have a tiny, rocky planet like Earth in the same system as a colossal ball of gas like Jupiter? They're total opposites. But believe it or not, understanding that puzzle is the key to seeing the beautiful, simple logic of our entire solar system. You see, the planets aren't just sprinkled out there randomly. There's a definite pattern, a real structure. It's like they're split into two distinct families. And the best way to see this for ourselves is to take a little trip, starting from the sun and working our way out. Okay, so here's our roadmap. First, we'll visit Mercury, Venus, Earth, and Mars. Then we hit this massive dividing line before we meet the heavyweights, Jupiter, Saturn, Uranus, and Neptune. Keep these two groups in mind because they are truly worlds apart. Let's start with that inner circle. All right, welcome to the first neighborhood. We're in the part of the solar system that's right up close and personal with the sun. And as you can imagine, things here are pretty hot, dense, and, well, solid. You know, the source material just nails it with this one simple phrase. It calls them the four rocky inner planets, and really that tells you almost everything you need to know about where we are right now. So let's meet them. We've got Mercury, Venus, our home Earth, and Mars. These are the terrestrial planets, which is just a fancy way of saying they have solid, rocky surfaces you could actually stand on. They're all relatively small, super dense, and made of rock and metal. But as we head out past Mars, the whole landscape of our solar system is about to change dramatically. So before we can meet the second family of planets, we have to cross this huge, sprawling frontier. And this isn't just empty space. Nope. This is a very real, very important boundary marker in our solar system. And that boundary is the asteroid belt. It's this massive ring of rocks and ancient debris, basically drawing a clear line in the sand between the rocky worlds we just visited and the giants we're about to meet. It sits perfectly in that gap between Mars and Jupiter. And get this. Just to give you a sense of scale, if you could somehow mush all the stuff in the asteroid belt together, you'd end up with a rocky planet about the size of Mercury. So think of it like all the leftover construction material that never quite came together to form another planet. Okay, we've crossed the border. The air is... well, there is no air, but you get the idea. The environment is completely different out here. So let's go check out this new neighborhood. And here we are, the outer solar system. Everything out here is just bigger. Everything is supersized. This is the home of the real giants, planets on a scale that absolutely dwarfs anything we saw back in the inner system. And again, the source material just hits the nail on the head. These planets are by far the largest planets in the solar system. That sheer size, that immense scale is what defines them. Say hello to the outer planets, Jupiter, Saturn, Uranus, and Neptune. Forget about solid ground. These are enormous spheres of gas and liquid, mostly hydrogen and helium. They're also famous for having tons of moons, and of course, those absolutely stunning ring systems, like the ones you see on Saturn. Okay, so let's just lay it all out side by side. It's pretty clear, right? On one side, you've got the four small, dense, rocky planets, all huddled up close to the sun. Then you cross the asteroid belt, and on the other side, you've got the four immense, low-density gas giants way out in the cold. It's two totally different types of worlds living in two very distinct neighborhoods. Now, I know exactly what some of you are thinking. Hey, what about Pluto? What about the ninth planet we all learned about in school? And that's a fantastic question. It's actually really important for understanding the modern map of our solar system. So Pluto didn't get kicked out of the club entirely, it just got moved to a new category, a dwarf planet. Here's the key difference. A dwarf planet is big enough for its own gravity to pull it into a round shape, but, and this is the important part, it hasn't cleared its neighborhood. That means it shares its orbit with a bunch of other space rocks and objects, which is why it's not in the same league as the other 8 planets. And that reclassification of Pluto really helps solidify our modern understanding. So the official count of planets in our solar system is 8. 4 rocky worlds on the inside and 4 gas giants on the outside. Simple as that. So let's bring it all back to that first puzzle, right? Earth and Jupiter. How can they exist together? Well, now we know. It's because our solar system isn't a random mess. It has this clear, elegant structure. These two distinct families of planets, neatly separated by the asteroid belt, are the fundamental blueprint of our cosmic home. And that kind of leaves us with one last really cool thought. This organized structure we have here, it's probably not a one-off. It might just be a common blueprint for how solar systems form all across the universe. So as we discover more and more systems out there with their own inner rocky worlds and outer gas giants, what does that mean for our search for another planet like Earth? It might just mean we know exactly where we should be looking.